Good Tuesday, everybody. It's Mr. Barron here again. Great to connect with all of you on today. And I am really excited for this week because we're finishing up this ARM project we've been working on for a long period of time. You remember we made these lovely drivetrains in um, class, but we didn't really get the chance to give them some sort of ARM extension on top of them. So we turned to a little bit of software called CAD, computer aided design, a 3D modeling software that helps us show what something is going to look like. And that allows us to use our design skills in a way that we haven't before. This is a really industry standard thing. And not going to lie, Mr. Hansen and I were grading your assignments from last class, and they were awesome. Super, super awesome and great job so far. On your original submissions of a robot with an arm on it, you've used Tinkercad to create a robotic arm design in lieu of the ones that we would make in class. And today's goal is to take it a little bit. We want to refine and finish all of the steps that are involved in designing that arm. And when we're done, we're hoping to give some brief presentations on Thursday over Google Hangouts. Mr. Hansen and I will get the chance to connect with you a little bit for the first time in a while, and hopefully you'll get the chance to show off what you came up with. So here's kind of what today is going to look like. I'm not teaching you anything. Mr. Hansen is going to teach you one new skill today. We are going to go back and look at maybe adding a few more components to our robot design if we haven't added them already. Then you're also going to look at some feedback from me that you got about last week's assignment. You'll complete a little Google form with your final assignment submission. You'll sign up for a presentation time for Thursday, and you'll make sure that you've met all of the requirements of the ARM, and you'll see a little presentation rubric so that you can prepare your presentation as you might want to on Thursday. First things first, you'll want to open up Tinkercad again. The link still exists on the Haiku page. And on today's Haiku page in step number 2, Mr. Hansen has a little video prepared for you where he teaches you about how to add some additional parts to a robot. In this video, you'll see some designs that are really similar to what you've done so far. We want to make your robot as thorough as possible. We want to think about all requirements that would be helpful. On the screen, you'll see a little demo that looks similar to what you guys submitted last class. By the end, we'll make some minor touches, but it should look something a little bit more sophisticated. Next, all of you received some feedback on your assignment from last class. If you need a little bit of a reminder, last class you completed this Tinkercad intro introduction survey. If you check your email, you should see a little bit of feedback from either me or Mr. Hansen telling you what looked good on your assignment and maybe where things could look a little bit differently. So if everything looked good, we probably just go to something like, hey, keep up the great work. If there's some things you want to think about, we might have noted, hey, where should this motor go? Are these shafts lined up the way they should be? Maybe here's a little change that you want to make. Next, and kind of the most complicated part of our assignment, we want you to complete this Google form on the robotic arm. I would say maybe take 15 minutes or so to finish up your Tinkercad design. This is really the meat of the assignment for today. First page will look pretty familiar, asking you to put in your email address, your name, who your teacher is. I'm Mr. Hansen's class. And the link from Tinkercad that you had last time. Remember you took it from the upper right-hand corner and put it in here. This should be the ARM design you've made with the edits based on Mr. Hansen's video and my feedback. It should be the same link that you submitted last time. Be a little more thorough than I am. Make sure you put the actual link in there. Next, we'd like you to tell us a little bit about your design. So, for each of the parts that you used. You might have a part type like C-channel or gear or shaft. Tell us the name, tell us what color you made it in your design, and tell us what it's used for. On this space, there's up the space for 10 different types of parts. You probably didn't use 10, but if you did, we left you space. Put as many of the different types of parts as you put in there. Then, something else we'd like you to consider are untinkerable parts. There were probably a couple important robotics parts that would have been required to build this robotic arm that are too small to make in Tinkercad. Some of the parts that we used in class. We want you to think about 3 of those parts that were a little bit too small to actually demonstrate in Tinkercad. Give their part name and explain what role it would play in each of these. Last but not least, this is something we would have done in class. We want to see how well your design actually works. We want to see if we can work through the steps to calculate the amount of weight that your robot would find helpful. Okay? And at the top of the 3rd page, you'll have the equations that we've learned so far in order to solve these problems. You probably used 2 gears. Check the boxes for which of the 2 gear sizes you used. You'll calculate the gear ratio, the output torque using the output torque equation that we have. You'll put in its arm length. This is something that you defined in your Tinkercad design, so you can go click on it. And when you click on it, it should tell you how long your arm is. And you'll use this information, your arm length and your output torque, calculate how much weight this thing can lift, which you'll hit before you submit. This Google form is kind of the submission for your big arm design project. And on Haiku, you'll notice that we have a little bit of space for a rubric. We're looking for appropriate parts and color coding. We're looking for the fact that you submitted 3 smaller parts. We're looking for your weight calculation, and we're looking for the fact that you have kind of a well-designed Tinkercad thing. Parts aren't kind of like apart from each other and all over the place. You got them aligned. You got them in the right places. Now, if you go to the bottom of your assignment, you'll see that we have some rubrics, some basics for what the little project presentation will and the requirements involved in it. Go ahead and take a look at these because on Thursday, you're not going to have any sort of new assignment. What you're going to have is to present your arm to either me or Mr. Hansen, depending on which class you're in. So, if you go to the presentation link in part 5, it'll open up a little Excel sheet. Make sure you fill this up before you're done. We'd like to meet up with you on Google Hangouts, if that's possible. We've got some sign-up spots during our normal office hours period from 2 to 4. We also have one later assignment. We know like 6:30 to 7 o'clock. We know sometimes people only get the chance to do their work a little bit later at night. If none of these times works for you, or if presenting your assignment over Google Hangouts is not going to work out, please shoot us an email to whichever one of us is your teacher and let us know how we can better accommodate you. So we'll wrap up with this today. These are the steps you got to take to have a nice, effective project. We're really excited to see what you guys come up with and are looking forward to finishing this up strong. Thanks for a great class, and let us know if you need anything as you work through today.